In the previous video, we looked at the waterfall model as described by Pressman. In this video, we'll continue our discussion of the waterfall model and we'll look at a slightly different version of it. But first, as a reminder, here's the waterfall model as described by Pressman: communication, planning, modeling, construction, and deployment. Now, here is the waterfall model as described by Royce, the person who first formally described the waterfall model in 1970. Interestingly, Royce gave the model as an example of a flawed development process that people were using at the time to try to build software. His criticisms of the model are similar to the ones that we talked about in the previous video. So what were some of his solutions to the problem with the waterfall model that he saw? Well, Royce proposed 5 ways to fix this model, but we're going to condense them into 4. The first is to build a prototype. This is great advice, and we're going to discuss prototypes in detail in the next video. The second is to provide more documentation and better documentation of your design. The idea is that the design is the most important part of the project, and everyone needs to understand the design. He also advocates what today would be considered good common sense testing techniques, like testers should be separate from developers, and tests should cover all logical paths in a program. We'll talk about testing more in a later module. Finally, the customer needs to be involved in the process. This is a recognition of the fact that if the customer is only involved during requirements gathering and delivery and nowhere in between, then the project is really doomed to failure. Typically, the original waterfall model is condensed into 5 phases: requirements, which encompasses requirements gathering and requirements analysis; design, which focuses on developing a system architecture; implementation or coding; verification or testing; and maintenance. This is what the waterfall model looks like if you view it on Wikipedia, for example. Okay, now we're going to look at some facts and figures regarding the software lifecycle. The data is not necessarily restricted to the waterfall model, but it does involve the 5 phases of development you see here. First, let's look at the relative costs in time and effort among these 5 phases. Before I show you the data, I'd like you to pause the video and guess the answer to 2 questions. So I don't want you to look this up, just give me your gut feeling. The first question is, in a typical software development project, which of the activities that you see here is the most time consuming? And the second question is, in a typical software development project, which of these activities is the second most time consuming? Ready? The most time consuming phase of the software development lifecycle is maintenance. Maintenance takes up to 60% of the lifecycle costs, more than all of the other activities combined. Can you believe it? Well, it might not be so surprising if you knew that within the maintenance activity, there were multiple mini life cycles. At least one life cycle for every new feature that your customers wanted to add after the initial version of the software had already been delivered. Okay, that's the first question. Now, from the remaining activities, which is the most time-consuming and the most expensive? The answer is testing or verification. On average, testing takes more time than requirements gathering and analysis. Testing takes more time than design, and testing even takes more time than the actual coding. In fact, testing takes approximately double the time of each of these activities individually, which means the remaining activities all take about the same amount of time. Very interesting statistics. Now, since we've discovered how important maintenance is, let's look at it in a little bit more detail. Here are some of the reasons you will find for maintenance. Adaptive maintenance is maintenance for the purpose of adapting the software to a new environment. For example, if the operating system that your software works on had been upgraded, and your software can't work on the new operating system, then you need to update your software accordingly. Corrective maintenance is simply correcting or fixing your software because it has bugs in it, and you need to get rid of them. Modifications or enhancements, that's all about adding new features to your software because the customers or the users want them, and you want to keep your customers satisfied. Finally, preventive maintenance is maintenance that you do to improve the design of the software and consequentially make it more maintainable. Nowadays, this is known as refactoring. We'll talk more about refactoring in the next module. Now, I have another question for you, but you don't need to pause the video for this. If I give you 10 seconds, can you tell me which of these reasons for doing maintenance on software is the most popular? And it may help you to know that the most popular reason is more popular than all the other reasons combined. Okay, 10 seconds starting now. Ready? The most popular reason is modification. Modification or enhancement is the most popular reason to do maintenance. It's you, the developer, responding to the seemingly never-ending demands of your customers. And here's the breakdown. Modification accounts for approximately 60% of maintenance cost. Adaptive and corrective maintenance account for just under 20% each. And preventative maintenance or refactoring accounts for only 5% of maintenance costs. Recall that from another slide that maintenance accounts for 60% of lifecycle costs. And here we see that modification accounts for 60% of maintenance costs. Robert Glass, who wrote the book Facts and Fallacies of Software Engineering, calls this the 60-60 rule. 60% of software's dollar is spent on maintenance, and 60% of that maintenance is enhancement. He ends the rule by saying, enhancing old software, therefore, is a big deal. Many of the statistics you see here were taken from the book by Robert Glass, and many of the statistics you see in that book were in turn taken from studies conducted by a famous software engineer named Barry Boehm, who came up with the spiral model. We'll talk about the spiral model in another video in this module. Finally, let's look at the maintenance life cycle. I put the development life cycle, excluding maintenance, off to the right here. If you recall, the three activities of requirements, gathering and analysis, design, and implementation all take about the same amount of time, but testing typically takes about double the time of each of these activities. For maintenance, it's similar, but a little bit different. Instead of design in maintenance, there's an activity that Robert Glass calls undesign. Undesign consists of trying to understand the design that's already there, so you can add to or change the underlying software. Remember, the person or team maintaining the software is usually not the same person or team that built the software, so they have to work to understand the original design. And that concludes this video, giving an alternative look at the waterfall model and giving a few interesting statistics about the software lifecycle in general. In the next video, we're going to learn about prototyping, the spiral model, and the rational unified process. I'll see you there.